My friends, welcome to my 200 3D CAD models in FreeCAD series. Today I want to work on exercise 138, which is a futuristic weird looking thing, but does not matter how weird it is, we will just build it. And I will be building it a quarter of it because it looks pretty symmetric on both sides. So cases like this, I have built only top right corner, and that's what I'm gonna do this time. And to do that, I am going to go ahead and set the center of the workspace at the center of the cylindrical hole on the right side. Alright, and take the axis cross away by pressing AC on the keyboard. Now if you see a different setup up here, it's because I'm using today FreeCAD 0.22 developers version, which is not released as a stable version yet, but it's pretty good. I'm just want to try it out. So if you don't see the buttons right at the right place, know that it's there, just it's hidden away or like tucked away, especially in the SketchUp. And speaking of sketch, let's go ahead and create a sketch on XY plane, and then we'll be building only half of it, right? And now looking at this is a tube. We can build it pretty easily, so let's not worry about the tube. Let's worry about what's surrounding it, which is an arc twice. Okay, I'm gonna go ahead and okay, now this is what I was talking about. So let's go ahead and join it. Here it used to be line and polyline. Now the line is tucked away with the polyline, which makes sense. So with the polyline comes with some advantages and something else, depending on what you think about it. But one of them is if you're drawing a polyline right next to an arc, it will take the tangential direction as by default. So hit M couple times since after you start that, and that will give you a free moving line, and that helps. All right, so these two are equal by default. I'm going to go ahead and apply some dimension on this one, which is, it says 76 diameter, so it would be 76 divided by 2. And the outside, do we know that? Okay, the outside is 100 diameter, so this is radius 50. Okay. And also the dimension wise, it's changed. Everything is tucked in here, and then you just hit D, and then it will pick the one best suitable for you. I like this system. Anyway, and now this line and this line, we can apply some angle constraint. So pick the two line, hit D on the keyboard, and then say it is 60, right? Pretty easy. Okay, what else? I think these two are not connected, so pick these two, hit C on the keyboard. That's a coincident. So here, constrained coincident with shortcut C. I'm trying this shortcut on the keyboard, and it makes life a lot easier. All right, so we got this one. That's our one sketch, and then so that thickness is different from the others. I'm gonna go ahead and then close it up, rename that as sketch. I'm gonna say color. It's a kind of like shallow color, but and I can see that that color is 5 millimeter from the bottom of the cylindrical, the tube that we'll be creating. I'm gonna go ahead and say that's our base, and then I will pick it up for 5 millimeter. So extrude that for 5 millimeter upward. Okay, we got that color set up. With that, let's go ahead and create the tube as a primitive. The outside diameter would be 76 divided by 2, right? and that's the radius, and then inner radius is 30. Okay, and height, so it is 25 in total. Let's go ahead and set it up for 25 right now. And then we remember, like, this is the origin, so we'll have to push it down for 5 millimeters. So let's go to the tube in the placement tab in the Z direction. Let's say it is -5, so that pushed it down just a little bit. So that's the theory. Let's see if it actually worked. So we're looking from the front. It does look like it worked, so that's a 5 millimeter gap. All right, we got that taken care of. Now our only other thing to do is these two bafflers or connecting beams, and that will be, we could do it from this primitive as a cube, but it has coordinate. This is, so we'll have to do it sketching anyway. That will be another sketch on XY plane, and we can start it from the origin, from the base. And I'm gonna go ahead and hide the tube. So we'll have to draw a construction geometry, an arc here to get a reference. So let's go ahead and pick, switch to construction geometry, right? And that's the shortcut GN, right? And then take the arc, bring it up here, and maybe take it up there. So this one is kind of like very tough to see, but that is diameter 80. Okay, we got that. Now, so we come halfway. So what we'll have to do is we'll have to draw another line, construction line. That would be 100 millimeter, because we'll be mirroring it over, and then place it on this. So that is our point. Now let's go ahead and bring the construction geometry to the real geometry and draw a couple of rectangles there. One more. All right, so we see where this needs to be deleted, these two, and place it on this arc. Also same for this. So the shortcut is C for that coincident. So it used to be two options before, one for points, one for arc on the object. Now these two are combined into one constraint coincident. Makes it easier. Then we can go ahead and close these edges. So close the wire. Okay, we'll have to fix that. Take one of the constraint off. I think it's the redundant constraint is this point on arc. Take that out, and there. Okay, make these two coincident and make these two coincident. Okay, so the outline is drawn. We will have to make these two equal. The equality constraint E on the keyboard, and then make these 5, is it 5 millimeter, I guess? Okay, 5 millimeter, and the gap between these two, so gap between these two is 10. And then we want to place all these 5 points in the same vertical, and that actually places something. Okay, let's take this out. Okay, so that's constraint, that's which is good. I see where these two got separated, so place them again as a constraint coincident. And then the height between these two is 20, which means this is 10. Okay, so I'm picking the points and then hitting D on the keyboard. That brings in this smart dimension and then applies the suitable one. Okay, we got these two beams sorted out. We have only 1 degrees of freedom, which is the radius, I guess. Okay, make these two coincident. And okay, don't know what's going on. So take these and this, and the distance between these two is 10. That should set everything straightened up. Fully constrained sketch. Now for these, that sketch should not have been that tough. I mean, that should not have taken that long from me. Alright, so the height of the extrusion would be 15, and there it is. So now we have the collar, the tube, and these beams. Since it is full, so we don't have to mirror it on this side. So what I want to do, I want to take these two and make them one piece, right? Then mirror it on this other side. So mirror it only these two, not these two. Mirror it on facing, okay, facing this, which is XZ. So we have to make these three one piece, right? So select all these three and then hit. That should make these all three pieces into one fusion. Now I want to mirror it over on this side against this face, and on the part workbench here, it gives you the option to select the face on the standard plane, or just take any other custom plane as our reference, and I want to pick this. I don't know if it's a new feature in 0.22. I guess so. Oh, this is great. I know that if you are working off 0.21, you still can change these values and then push it over, but this is great. So I want to mirror it against this surface and hit OK. That actually does the trick. I think that's our object. We just have to place these two in a one object, in a fusion, and that is our object. Very simple. We just have to know which one to pick before we mirror it over. Well, I hope you liked this process. Thank you for watching. If you have any question or comment, please let them know in the comment section below. I will see you in the next video then.